Okay, so what we'll have a look here at these particular parts in the notes is just, it's worthwhile looking at, there are some special cases for the values of 0 degrees, 90 degrees, and so on for sine and cos. First of all, let's look at understanding our unit circle a little more. So if we have a look at this value here, which is an angle of 0 degrees, okay, remember that sine is our y-coordinate and cos is our x-coordinate. So at this particular point here, okay, think of this as our xy plane. Then at this point here, our coordinate has an x coordinate of 1 and a y coordinate of 0. So sine of 0 would be 0, okay, and cos of 0 is 1. All right, because that's our coordinates there, is 1, 0. If we work our way around here to 90 degrees, okay, so we've got an angle of 90 degrees here, and our y-coordinate is now 1, and our x-coordinate is 0. Okay, so sine of 90 is 1, cos of 90 is 0. If we work our way around to 180 degrees, then our y-coordinate is again the same as it is here, okay, which is 0. And our x-coordinate this time now is at -1. So sine of 180 is 0, cos of 180 is -1. 270 degrees is here. So our y-coordinate now is at -1. So sine of 270 is -1. Cos of 270 is 0. Okay, so just some really important points and very important to remember in terms of these values here. These, of course, are in degrees. In radians, we've got 0. 90 degrees, the equivalent radians is pi over 2. 180 degrees is pi, and 270 degrees is 1.5 pi, or 3 pi over 2. And of course, we can go around to 360 degrees as well, can't we? So 360 degrees, which would be the same as 0, which is 2 pi radians. Okay, so we've had a look at these values here in the notes. Let's have a look now at this part here where we're looking at exact values for some particularly important angles. Okay, 60 degrees, 45 degrees, and 30 degrees, which relate to pi on 3 radians, pi on 4 radians, and pi on 6 radians. Okay, so in terms of understanding how we obtain exact values, what we're looking at are some particular triangles. And so this angle, this first triangle here, this is an equilateral triangle. So we've got 60 degrees in here, 60 degrees here, and of course each of these would be 30 degrees. Okay, and what we have is each of these sides, 2, 2, and 2, and of course that's split in the middle, that makes 1 and 1. Excuse me. So if we think about our understanding of right-angled trigonometry, we'd remember that, so I'll just write it down here, sine theta is equal to opposite over hypotenuse. So sine of 60, and here's our angle 60, is opposite over hypotenuse. What is the length of this one here? Well, if we consider Pythagoras' theorem, which is the sum of the squares of these two sides is equal to the square of the hypotenuse. This would be 2 squared, which is 4, and this is 1 squared. This would be root 3. Okay, if we go, say, 1 squared plus root 3 squared, that's the same as 2 squared. Okay, so this length here is root 3. So sine of 60 is opposite over hypotenuse. That's root 3 over 2. So sine of 60, which is the same in radians as sine of pi on 3, is equal to root 3 over 2. Cos of 60 is going to be adjacent over hypotenuse. So here's our adjacent side. That's our hypotenuse. It's 1/2. And tan of 60 is opposite over adjacent. So that's root 3 over 1, or just root 3. If we look at our angle here of 30 degrees, then sine of 30 is opposite over hypotenuse, which is 1/2. Cos of 30, adjacent over hypotenuse, root 3 over 2. And tan of 30, opposite over adjacent, which is 1 over root 3, which if we were to rationalise the denominator, that is equivalent to root 3 over 3. Okay, when we're looking at 45 degrees, that's what we use this triangle for. So here we have a 45-degree angle. This is a 45-degree angle, and we have 1, 1, and using Pythagoras' theorem, this would be root 2. So sine of 45, we could use either of these angles, is opposite over hypotenuse. So that's 1 over root 2, which is the same if we rationalise the denominator as root 2 over 2. Cos of 45 will be exactly the same, okay, but it's adjacent over hypotenuse. So it's also 1 over root 2, or root 2 over 2. And tan of 45, opposite over adjacent, which is 1 over 1, or 1. So tan of 45 is 1. So then, if we were to look at, in summary, what these exact values are, you can fill those in, okay, and you'll find them on our exact values table in the information sheet. The exact values the table in the information sheet only has it in radians. It might be worthwhile, just so you get used to it, on your information sheet that you have, to write the equivalent angle in degrees. So for 30 degrees, sine of 30, or sine of pi on 6, is 1/2. For 45 degrees, is 1 over root 2, or root 2 over 2. Okay, it's really important that you become familiar with both these representations to understand they're the same. For sine of 60, or pi on 3, is root 3 over 2. Sine of 0 we saw is 0. Sine of 90 is 1. Sine of 180 is 0. 270 is -1, and then 360 we're back the same as 0, which is 0. Okay, for cos of 0 is 1, cos of 90, 0, cos of 180 is -1, cos of 270 is 0, and then cos of 360 is 1, and then to tan of 30 we said was 1 over root 3, or root 3 over 3. Tan of 45 is 1, tan of 60 is root 3, tan of 0 is 0. Tan of 90, remember, is undefined, put UD for that, because remember the tangent line's parallel to the y-axis, and so they'll never intersect, so that's undefined. Tan of 180 is 0. Tan of 270 is also undefined, and tan of 360 is 0.